We're talking about solving quadratic equations by completing the square. And for this example, we want to solve quadratic equations by using the square root property. And the square root property can only be used to solve quadratic equations when the side containing the quadratic expression is a perfect square. So in this case, we have if x squared is equal to n, then x is equal to plus or minus the square root of n. So when we solve this to get x by itself, we take the square root of both sides. And whenever we take the square root in solving, we have to make sure that we use plus or minus with the square root side. So here's an example. X squared equals 64. So if we take the square root of both sides, because that's the inverse operation of an exponent. So x squared, the inverse operation is square root. So we take the square root of both sides. On the left-hand side, the reason that we did the square root is so our square root could cancel our square. And then we're just left with x. And then on the right-hand side, we can use our calculator, or we can know that the square root of 64 is 8, because that means 8 times 8 equals 64. But remember, we have to keep it as plus or minus. And the reason that we have to keep it as plus or minus is because negative 8 times negative 8 is equal to 64. And positive 8 times positive 8 is also equal to 64. So that's why we have to do plus or minus when we're solving, because this value squared here, so x squared, we could square negative 8 and get to 64. Or we could square 8 and still get to 64. So that's why we have to count for the minus and the plus right there. So here we have another example. And in this case, we'd like to rewrite the left side of the equation as a perfect square. So we can factor this side over here. We're not going to do anything with the right side right now. We'll just leave it. So we want to factor and see what we can come up with. What two numbers multiply together to get to x squared? That's going to be x in x. Now we need two numbers that multiply together to get to 49 and add to 14. So that's going to be 7. Okay. So now we understand that we have something multiplied by itself. So the binomial x plus 7 times x plus 7. And we can rewrite that as x plus 7. And then we're going to take that whole thing and we're going to square it. Because there's 2, so we can square it because it's joined by multiplication. And then that's equal to 64. So we're in the same situation, basically, that we were over here. We have something squared is equal to 64. Well, here we have the binomial squared is equal to 64. Well, we still want to use GEMDES again. Remember, that's the same thing we did over here. And we're solving. So we're going to start from subtraction and addition and work our way to groups. We do have addition, but that is inside the group, and the group happens last, so we can't deal with that addition yet. So the only other thing that we have is that exponent, and that's the first thing that we're going to deal with. So we want to take the square root of both sides to get for the inverse operation. And when we take that square root of both sides, what happens, the reason that we did it is the square root on the left side cancels the square. So then we're left with just x plus 7. And anytime we take the square root when we're solving, we have to count for plus or minus. So plus or minus 8. So we really have to solve two different equations now at this point, because we have plus or minus 8. So we have to solve the equation, which is x plus 7 equals negative 8. And then we also have to solve x plus 7 equals positive 8. So now we go back to our GEMDAs. We've eliminated the group. So now we can go back to the beginning and we see that we have addition. So the inverse of addition is subtraction. So we subtract 7 from both sides. And we get x is equal to negative 15. And we do the same thing here. We subtract 7 from both sides. But in this case, we have a positive 8. So 8 minus 7 is 1. So x is equal to 1. So our solution in this case ends up being x is equal to negative 15 and positive 1.